to my problems on implicit functions. Remember, in the last video, we ended on finding the derivative of a function that is defined implicitly like this. So we ended at this, but this time around, we're going to look at how we can simplify further if we have been given conditions such as this. So what is the problem? The problem is to find the equation of a tangent at a point on a curve. So a tangent at a point on a curve is given by, first of all, what you should remember is that if this is a curve and then you draw any straight line at a given point. So this line, by the way, it should just touch the curve and it should not go inside the curve. So suppose this is the point, okay? So we can find the tangent at this point. So normally, I don't worry about this other line. I was almost tempted to talk about the normal and the tangent, but the normal I'll talk about in the next video. For now, I'll talk about the tangent. So here is how it works. So this point is actually M, and M is the tangent, which is given by dy over dx. So it is the gradient. So it is the gradient of this line, sorry, the gradient of the curve at this point, which is given by that line. This is our focus. So once you differentiate this and come up with this, then you can substitute in your function such as this one, the condition is given, then you find this value of the gradient. So let's do it. First, we differentiate. As you can see, 2x squared, when you differentiate, this becomes what? 4x, okay? Minus, now you see that this is the product of two functions, x and y. So we shall use product rule, where, let me write first the variable out. So we can say, keeping x constant, I'll write x, and then I'm going to differentiate y. If I differentiate y, the answer is just 1. But I'm differentiating y, so I'll write dy over dx there. The next thing is to add. This time around, I'm going to keep y constant. So I'll write it, and then differentiating x, the answer is just 1. So 1 times this, so it just becomes that. Okay, so that's what we get, minus y squared. Now differentiating this, it is as simple as similar to what we did earlier. So this becomes 2y, but we're differentiating y, so we attach the dy over dx. The last one is to differentiate a constant, and we know derivative of a constant is 0. So there's nothing there. Our job now is to put these together. First we expand and then collect the like term and so on. By the way, we can even take this the other side. So if we do that, we have negative 3x dy over dx, that is this part, and then this multiplied by that. Okay, so the answer becomes minus 3y. Then minus this one, 2y dy over dx equals, now this one I can even shift it to the other side, so it becomes minus 4x. Okay, so this is what we get for now. So a reminder once again, this negative 3 is multiplying all this. So you should not forget to distribute the negative 3 to all these. So again, we collect this and this one, and then this one will go the other side. So we can write this as negative 3x dy over dx. So perhaps I can even factorize, but before that, let me write first this equals. Now this one will join with this. This is negative, so when it goes the other side, it becomes the positive. So it will be 3y and then minus 4x. So the job now is to factorize dy over dx. So plus a negative is common, so it is minus dy over dx. Then what is going to remain? Definitely is 3x. So we write 3x. What will remain here is plus 2y, because I'd already factored out the negative. And this whole thing is equal to 3y minus 4x. And then our focus is to find dy over dx. So we are going to divide throughout by this, both sides. So if we do that, what we get plus the negative, by the way. So write dy over dx is equal to this quantity is 3y minus 4x. All this divided by negative, in this 3x plus 2y, like that. So that is the result that we have. If you want, you can write further this, but even if it's the way it is, it's still okay. You can write it nicely as 3y minus 4x. All this divided, I put a negative there. 3x plus 2y. So this is the expression for gradient n. Okay? So once we have this, the next thing is now to substitute. Remember, this is a point. So at this point, we have x as this one. This is x, and this is y. All right? So it's like this. So where there is x, we're going to substitute with the x, we put 2, the y, we put 1. So finally, let me use this part so that it's a small thing. So dy over dx becomes 3, of course there's a negative. Where there's y, I put 1. Where there's x, I put 2. And then divided by 3. Where there's x, I put 2. Plus 2. Where there's y, I put 1. And then simplify. This and this negative is multiplying everything, so we begin with what is inside. So this is 3 minus 8. Answer is negative 5. Negative 5 times that. The answer is still that. Again, 3 minus 8. Negative 5. Negative 5 times negative, positive. Then the denominator, we have a 6 plus 2. Answer is 8. So this, my friends, is the expression for the derivative of this implicit function. So if you want, you can even write this as a decimal, or leaving it as a fraction, the way it is. Yeah, so thank you very much. Remember to subscribe to my YouTube channel. If you like my videos, you'll be receiving more. Thank you.